All right, Chapter 2, Chapter 2, Static Characteristics, Accuracy, Resolution, Symphony, Deadband, Hysterias, Linearity, any statistical character of the component of the automatic control system, which determine operation quality, although the characteristics might meet the requirements for the cave, the unnecessary, for the refinements, for the void, for the region, for the economy, through the knowledge of the static characteristics, necessary for the realistic peer appraisal. One of the difficulties governing static characteristics are overlapping when the terms of accuracy include the scale of the calibration errors as well with the result of the resolution, sensitivity, deadband, hysteria, for the linearity, resolution, sensitivity to do with the static friction. For instance, we call break loose force for the discontinuity of the lunge, for the potential piezometer. Deadband includes static friction and discontinuities as well with the loss of motion, hysteria. Statistically speaking, only electrical and mechanical and material property will be discussed later. However, the term of the control system component with the hysterias can generally not be separated with a deadband with nonlinearity. It may be occasionally to be convenient with a consider with a hysteria that include hysterias, power, deadband, and nonlinear. Accuracy with the figure 2-1 for the block diagram. Act with the component with the control system. Input, output with a relay with a mathematical function with the correct value. Input, component, output. Control system, for example, the component of the figure 2-1 may be the pneumatic control, which include with the control point setting mechanism. The input may be the temperature, maybe a temperature, and the output may be a pneumatic signal at 60 degrees Fahrenheit with the controller output per signal. Is PSI 3 PSI at 120 degrees Fahrenheit. It is 15 PSI. The mathematical function applied with the range of 60 degrees to 120 degrees Fahrenheit, as in P equals 0.2 times 9. P is the correct pressure of the control output signal, T for the input, and the temperature of the output value with the correct value with the because of the inherent imperfection controller degree to which output value and approach with the correct value with the accuracy. Accuracy may be the correct with the input with the percent with the output range and percent with the value with the accuracy for the determined the extension of the percent and specification which is not related with the sum of the specific magnitude of the meaningless. In this case, with the aforementioned with the temperature control with the output with the read of 15 psi with the accuracy may be detailed with the 1% range. If the controller has the range of 100 degrees Fahrenheit, output signal differs from the correct value of more than plus or minus 0.2 psi. This is derived considering 1% of the 100 degrees is equal to 1%. Since the output signal changes 12 psi for 60 degrees Fahrenheit, changing the equivalent in 1 degree with 0.2 psi, if the pressure of the output with the maybe above or below with the correct value. Specification accuracy the number to leave the other several the question with which relate. Mostly conditions under the accuracy to determine, for example, the temperature relative to the humidity may be considered with the influence of the accuracy of the pneumatic control will show with the inaccuracy of the change with the air temperature, which may not reflect the accuracy statement. The acceptable change within supply with the voltage, line frequency, supply, air pressure, hydraulic pressure may have been to be specified before accuracy rating becomes meaningful. Bourdon 2 pressure gauge, for example, is usually accurate with plus or minus 0.5% within its range, with the gauge respond with the difference between the process of pressure and the atmospheric pressure. In fact, with an instrument with a measure for the differential pressure is calibrated with the 15 psi gauge or pound per square inch gauge pressure, really measured for the 30 psi pound per square absolute pressure, minus the atmospheric pressure. Let's say the gauge calibrated with the atmospheric pressure for the 15 psi and since the pressure may vary, since the pressure may vary from plus or minus 5% of the valve with the gauge pressure has accuracy of plus or minus 2.5% of the range of the atmospheric pressure condition. This must be added with the temperature error, which is usually added to order with a plus 2% for temperature rising 100 degrees Fahrenheit. Accuracy specification for their left open to the accuracy figure with the result of the number of readings, which the average of the if it refers to the value of the input only obtainable for certain values in order to give it the federal indication of the worst reading over the whole range. If the one reported is not the case within the condition the accuracy refers should be saved with this resource. Of course, equally true for the other specifications like a deadband, resolution, sensitivity, etc. Calibration errors. Calibration errors belong with one or both of the two categories. Zero errors, angular error, zero out of the linear shift of the range. For the example, the output may read with the 2 units, the output with any of the throughout the range. There is zero error with the adjustment consists of the linear shifting range for the obtained with a correct with the zero reading. Angular error, so correct reading with the arbitrary point with the scale of the zero with the point with the error with the increase of the proportional with the difference with this point with the required of adjusting the ratio output input relationship, which is usually accomplished by changing the lever ratio of the mechanical linkage of the gain with the electrical circuit to increase or decrease output signal range for the given input range with the zero errors. Angular errors frequently combined with the overall calibration error. requiring separate adjustment. Resolution sensitivity. Resolution sensitivity is the minimum change of the measure variable which produces the effect of the response of the component of the control system. Steps over the resolution sensitivity spring up over the diaphragm control valve to be used to determine the input air pressure signal. The output is the stem motion. The air pressure of the rate of the arbitrary value of the stem is allowed to come to the rest. Next, the air pressure with the further increase, but now with its very small increments in order to determine a minimum increment required with the start of the stem moving. Let a minimum increment of 0.012 psi for the pressure range of 3 to 5 psi, or 13 to 15 psi. That means the resolution sensitivity is 0.1%. Resolution sensitivity with the K for the express the force of the required with the introduced physical system to produce motion is due to the static friction, sometimes called stiction. Another cause limited resolution sensitivity due to the built-in step of the arrangement of the wire wound rheostat. Resistance can be changed with a discretely step them since one winding for another is shunted out. Each winding is somewhat of finite resistance. Resistance as one winding corresponding thus the resolution sensitivity of the rheostat. In this case, if the rheostat with static friction is probably with the percent of the resolution sensitivity called for the both static friction and the winding resistance. In no case loss of motion include the resolution sensitivity and the deadband hinge for the viewpoint with the actual operation condition. Significant resolution sensitivity becomes questionable over the input signal may either be increased or decreased with essential questions. How much input change for the reducing response for the output, however the deadband with the no resolution sensitivity test for the later the signal change in one direction only with the not reverse actual operation specific resolution and sensitivity interest only if it is desirable to separate loss of motion and analysis. Deadband. The range of values through the input that can be varied without the initiating output with the response that is defined is deadband. But this is not only the limiting factor accuracy of the component, but is also the most important operational quality criteria. Statistic character for the automatic control system with flow control with a range of 100 gallons per minute. It has a deadband of plus or minus 1% range, which means it's controlled with 60 gallons per minute. The actual flow rate may vary between 59 to 61 gallons per minute without producing action. If the flow has 59 gallons per minute and now begins to increase with no action made to be taken the flow until the flow is 61.1 gallons. This means not only will the control variable is able to change from through 2 gallons per minute without correction, the taking place of the flow continue to increase and the controlling action is delayed. The equivalent is dead time, contributing to the instability of the control group as discussed in the following chapter. The cause of the deadband is static friction, discontinuities, resolution sensitivity plus loss of motion. The most common cause of the loss of motion is probably backlash, refers to the looseness of mechanical linkage in gears. Therefore, however, the other causes of loss of motion, such as the overlap between the spool lands and ports and the valve, as will be discussed in chapter hydraulic control elements. Linearity can be expressed with the number of ways shown by the following number over the independent layer and linearity. Illustrated figure 2 to show the express of the minimum deviation output values, full line, but a straight line, dead line, dash line, and may be drawn through the value considered with the scale of 10 units maximum deviation in figure 2 unit with a 1 to 10%. Zero base linearity illustrated in figure 2-3 with a dash line with a linear refers base and with through 0 with the illustrated with the maximum deviation with the lines about 1.3 to 13%. Alright, so the output nonlinearity, correction values, the automatic control, the geo-based linearity, output values, corrective control. Absolute linearity, neither normal nor zero linear express action for the output value with compared with the correct value with the resulting deviation linearity considered with the large and shown figure 2-4 dash reference lines and the idealized output with the correspond with the correct value with the greatest deviation is now 1.6 units or 16%. This is absolute linearity. In no case the linearity necessarily does include backlash, hysteresis. Consists of values obtained with the change of the input signal in one direction only with the cover of the nonlinearity general mechanical electrical imperfection. Hysteresis is stated before that the hysteresis curve of the control component, but generally they cannot be isolated with the effect with the deadband and linearity, and that it therefore convenient to consider the high hysteresis curve of the angular meridian of these characteristics. Hysteresis by itself, however, the inherent physical characteristics of the materials used is distinguished from all other characteristics as discussed, which are based on internal relationship of the elements within the component. Magnetic hysteresis. It shows a core winding and magnetic hysteresis. jumps into discrete quantity known as physical scientific ignore with the connection but irrelevant practical behavior of the control system hysteria that may be magnetic or mechanical, as shown in figure 2.5 and 2.6 respectively. Both graphs show output-input relationships of mechanical hysteresis. Physical specimens, in this case figure 2.5, input with the magnetic hysteria with the H due to the proportional current in the winding, the output of the result of the magnetic intensity of magnetic flux B. Figure 2.6, the input with the stress F is the force applied with the elastic specimen, which results with the stream of the deformation as equivalent to the output. In both cases, the output in relation with the dependent with the previous history of the specimen. Initially, they are both zero, but once the input signal that has been applied with the remains memory with the signal of the specimen coupled with the retentive of the remnants. The magnitude of the remnants depends with the amplitude of the input signal. The input signal cycle with a smaller cycle with the hysteria becomes less noticeable, but therefore necessary to specify the amplitude of the input signal to give it in hysteria values. Occasionally, deadband and hysterias are used as equivalents. Deadband, however, refers to the change of the input without input response. Under what conditions hysteria does not appear at all, the two terms relate entirely different characteristics. Linearity hysteria of the control system. Whenever the reading of the control variable would require both linear and hysteria, the measuring of the means of the effect with the directly accuracy of the reading, an important criteria for the control function, however, can tolerate considerable nonlinear hysteria in any part of the loop without deterioration of the performance. Figure 2.7 shows simplification. Figure 2.7 shows the basic control system. You have the process going to the control point and set point, going into the controller, going to the process, the load change of the processor, and then back to the controller. Figure 1.1 shows the control system reduced to the control of the process. In this case, the controller is supposed to incorporate with both the measuring means of the final control element, the controller action upon the process action upon the controller. Changing input profit of the controller result with the modification output with the control of the produce the corrective action corrective in process with the result and the modification input with the control of the component from the process with the step with the mediate once for the happens with the indicate succession only once the linearity hysteresis control would be very important physical reality. However, in this change with the gradually they may be have because of the interaction closed loop with the self-correcting system set up as many with the non-linear areas can be absorbed. Typical example of the industrial control valve, which we'll discuss in a separate chapter for the term of the pertinent fact with the anticipated here that the control valve is part of the control of figure 2.7 and adjust manipulated variable flow, in which part of the process relation between the chain with the manipulated variable to respond with the gun control of the control variable. The character of this process is generally not but the subject of the alteration. The relation is not a linear one. Further depends on the nature of the load change in order of the compensator of the leaf partially with the non-linearity of the process of the valve plug is generally characterized flow versus stem travel the character of the valve with a certain pattern, and this is also approximation since the characteristic derivative deviate largely with the ideal curve of the lack of the accuracy that exists between the non-ideal value of the characteristic as well as because of the non-ideal of the non-constant process characteristics. It's quite obvious that under the such conditions it is not realistic to look with the excessively linearity freedom of the hysteria of the valve position and any other control system component. Non-linearities have changed with the ratio between the corrective action deviation control variable with equivalent change with the sensitivity and the control of the conceivable non-linearities become so in a certain valve position that the system becomes unstable, the corrective action becomes too slow. Characteristics evidence is described in the chapter refer over the output input with the relation component with the control system, the condition of the investigator, the where those that exists after the system, and the undergone with the change of the input with the return of the balance steady state of the condition. No attempt has been made to discover the behavior of the valve of the change that takes place with discussed in the following chapters. Chapter 3, step function response of a process.